4.3 lesson 27 is dealing with polynomials. Basically here we're going to talk about the type, the degree, and the form of polynomials. The vocabulary terms are going to be your friend for this unit. Coefficient, we've talked about it before, simply a number in front of a variable. Polynomial, the term polynomial are all you're dealing with here. Everything is called a polynomial. There's just more specific names, such as monomial, which you've been doing a lot of working with, multiplying and dividing different monomials. You have a binomial. A binomial is the sum or difference of two or more monomials. Trinomial would be the sum or difference of three monomials. Degree of a polynomial is the greatest degree of any term in the polynomial, and we use this degree to basically put things into the next term standard form of a polynomial. It's written with the terms in order from greatest degree to the least degree. And your degree, when you get into graphing, dictates what graphs look like. Leading coefficient is the coefficient of the term with the highest degree. So whatever has the highest exponent there, the leading coefficient, the number in front of that variable, is simply the leading coefficient. So the degree of a polynomial, if it has no degree, it is a constant, which would simply be a number, such as 23. Degree of a polynomial, if it's to the first degree. Think of when x has the power of 1. Okay, x to the power of the first, you just normally write it as x. This would be a linear graph. When it is squared, it creates that quadratic graph, the U-shaped graph. And then third degree would be cubic, and so on and so forth if you look at those other degrees. So the graphs will change based upon the degree of the exponent. First things first, we're going to go ahead and get an idea of what polynomials we're working with here. So we need to identify the polynomial as a monomial, binomial, or trinomial. If you look at this, this has two terms that can't be added together. And again, it says the sum or difference. In this problem, it's a difference of two terms that cannot be combined. So there is no CLT, combining like terms. This would be an example of a binomial. So this is a polynomial. The next example is a polynomial. This here is an example of a monomial. So again, a polynomial. Next example, you have 7a to the negative third plus 9b. This is not going to be, a lot of people would want to say that this is a binomial. It's not, because you have a to the negative third. And we've talked about negative exponents. Okay, you need to get rid of the negative exponents. So basically, a to the negative third moves to the bottom. So you'd have 7 over a to the third plus 9b. Anytime you have a variable in the denominator, it is not considered a polynomial. D. Looks like I have four terms here that I would say, yep, this is a polynomial. It's not, because I can combine like terms. I have a positive 4x and a positive x. When I combine those, I would get a 5x. So essentially what will happen here is it'll go from, looks like 4 terms down to 3 terms. So yes, this is a polynomial, and it would be considered a trinomial. E, kind of similar to C. Okay, you have a variable in the denominator. Variable in the denominator. This is not a polynomial because you have a variable in the denominator. D, you look at these. Looks like you have 3 terms. None of them can be combined. So this would be an example of a trinomial. So yes, this would be a polynomial, and the type would be a trinomial. When you find out the degree of a polynomial, basically what you'll want to do is break each term down. So you have 2 terms. This would be an example of a binomial. We're going to take 6a to the second, b to the third, and write that down, and 9. When I do that, to find out the degree, you simply add the exponents. So of the variables, that is. So you'd have a has the power of 2, b has the power of 3. When I add them together, I would get, this would be an example of a 5th degree polynomial. 9 does have an exponent, but we're only worried about our variables. So 9 is really considered a constant. Next example, you have 3 terms here. So I'd go ahead and write all 3 of those terms down. 8d to the 5th power would obviously have an exponent of 5, or a degree of 5. When I combine my c and d, I add those together, 3 plus 4 giving me 7, and then 7 is a constant, so it would be 0, the degree of 0. So in this problem, you name the polynomial by the highest degree. So you'd have a 5, 7, and a 0. The 7 would be the highest degree, so this would be a 7th degree. If it says name the degree of the polynomial, that would be back on your chart back here. So you'd look for a 7th degree, and it simply says 6 or more. You're just going to basically name degree. So that's why I came up with a 7th degree. In example 1, you would actually, the 5th degree, the name of a 5th degree would be quintic. So naming the degree versus stating the degree. See, I'm going to go ahead and have you pause the video and give that a shot there. That is an example of a monomial. So pause the video and determine the degree of the polynomial. You should have come up with a 6th degree. So A has an exponent of 1, B 4, C 1. So that would be an example of a 6th degree polynomial. Go ahead, pause the video here and give D a shot. After you write those degrees down, you would name this a 5th degree polynomial. Next section here, we're going to write things into standard form. The degree helps us write things in standard form. So in example A, you have a trinomial here, and if you were to write the degrees of the trinomials, you would notice that this would be a 2nd degree, this would be a 5th degree, and that would be to the 1st degree. Basically what you're doing here is to put things into standard form, you put the highest degree first. So you'd have a positive 9x to the 5th, followed by the 2nd degree, which would be 4x to the 2nd, and last, negative 7x. So that would be in standard form. The leading coefficient is the number in front of the lead number in standard form. So the leading coefficient here would be 9. B, taking care of this polynomial, we're going to call it a polynomial because it has 4 terms, none of them which we can combine. 9y has a degree of 1. Negative 9 is a constant, so 0. 9y to the 4th is a 4th degree. And 5y to the 3rd is a 3rd degree. Again, putting things into standard form, you're going to write it by its highest degree. So negative 9y to the 4th is the highest degree. That needs to come first, followed by plus 5y to the 3rd. And then we'd have a positive or plus 9y, followed by our constant minus 9. The leading coefficient here would be negative 9. Go ahead, pause the video, and work through the next 2 in the skills check. Here's my degrees that I would have. Again, putting in standard form, highest degree first, along with my leading coefficient. In D, find out my degrees. Writing in standard form with the highest degree first, and my leading coefficient. This will conclude lesson 27.